Back with another update on Project Electrollite, the 1972 Plymouth Satellite Tesla swap. This episode I'm working on the dash panel and continuing on with some other wiring. I wanted to use the factory dash panel because it fits in the car very nice, but I didn't need the factory radio anymore. I started with making a lower skin. This is designed on fusion and then cut out of aluminum. Now it houses these three rocker switches. The cruise control is a momentary forward and reverse or latching, and then double momentary for the parking brake. So that'll be for the motor controls. Next, I wanted to house a couple of tablets. I'm going with Android tablets, two 8-inch side by side, so I needed to 3D print a mount. This mount clips around the tablet, so it'll actually be removable. You can kind of just flex it to get the tablets out of the dash if you need to. In order to make them fit and charge, I had to convert them to wireless charging, so I've mounted a wireless charger on the back of the tablet, and then I disassembled a fixed base wireless charger and mounted the components onto this 3D print. Now I can fit the USB wire in behind, and that'll be powered anytime the car is either plugged in charging or when the ignition turns on, the charger comes on, and that will wake up the tablets. I'll be using the Torque app, and you can see there's one tablet, the other one will be side by side with that wireless charger behind it. So you can just pop them in and out, and when they receive the power, they turn on just like a dash would. You can decide which side you want to have either a moving map or instruments or both. But this worked out really well because I can still have the factory headlight switch and factory wiper switch. And you can see it looks kind of like a panoramic view now with the instruments. The instrument side is Bluetooth to the battery management system, which will get data off the CAN bus from the batteries as well as the Tesla motor. On the right side, it's got a 4G chip in it, so it can get updates for moving map or music. I'm starting to assemble the rest of the rocker switches here. Just made a lower panel. Just using full-size rockers. They're easy to use. They light up nice. I've got a PWM light control to dim the LEDs. They're on full bright right here. There's also a Bluetooth rocker switch stereo unit. It's made for side-by-sides, but I didn't want a big stereo since I've got the tablet to run everything. This right tablet is Bluetooth to that lower rocker, which is a volume control, and works really slick. It connects right away, so touch screen, and if you're sitting charging, you can watch movies or do whatever you want to do. Makes for a easy to use and kind of a nice look. It turned out better than I expected. Here's some more of the controls. That red boxed controller, that's the variable pressure for the power steering, so you can change it up. And then on the left, I've got my thermostat control for heat and AC. Built an aluminum battery tray. This goes in the trunk. This is for the 12-volt battery, so a lot of people were surprised this has a regular car battery as well, so just did a trunk relocation. This is on the driver's side, is where it fit the best. I punched some holes and installed some riv nuts. The trunk floor is a little bit uneven here, so I put the tray in, and then the angle mounts that hold it up, I sized them in place and welded them so it's got a nice square solid mount now, all bolted down. And it's just a regular AGM battery. This gets charged from the battery charger. Has a DC to DC converter built in, so it'll take 400 volts from the high voltage pack and step it down and charge this just like an alternator at about 125 amps. Now I'm ready for some battery box assembly. These are the high voltage batteries. Right now they're all wired in parallel. I was balancing the charge across all of the different modules. And then I started to sort out all these battery management wires and thermistor wires. There's 6 or 8 wires that go to each module. And first thing to do is take off the original balance board. You can see these thin tape connectors. The yellow and blue are the thermistor connectors that monitor the temperature of the battery cells. And you can see each individual cell there. I've installed a cell tap board from Stealth EV. And once the modules are squared away, then I've got them isolated with these mica sheets. These came out of a Tesla battery pack. So there's a mica sheet on either side of each module. And starting to mount them and wire them in series. These bus bars also came from Stealth EV. And they go from positive lower side up to the upper side is the negative. So all 16 modules will eventually be in series. This is a box of 6. And you just stack them up. I've mounted them to those rails that are riveted to the side of the box. And then I also have some stop bars front and rear. As I went, I installed the battery management connector that taps into all the different cells, 6 cells per module. And just work my way up. The input and the output of the total box here will be with those 2-aught cables that'll connect to the other batteries in series. Here's a look at the rails where those modules mount. So they're kind of setting on that 1/2-inch aluminum angle. They're screwed down to those rails. And then just for a little extra assurance, I put a vertical piece of 1/2-inch angle, and that allows it to have a stop bar front and back. This is the cooling side. You can see more stop bars on this side. These have dual cooling loops per module. Every single loop needs to run in parallel. So here's all the fittings installed in the batteries. Here they are with tubing. So input and output, left and right, I needed to make a manifold. And I want the manifold to have a pass-through bulkhead so I can connect it to the rest of the cooling system. So I started with this square tube aluminum. This is 1-inch 1/8 wall. Welded it through the lid of the box, so it's got a sealed bulkhead, and then I just welded a fitting onto those tubes, and that's a 3/4 inch pipe fitting. I'll be putting T's or elbows on this, but like I said, every box is in parallel. Every module is in parallel, and each cooling loop. So here's what it looks like all plumbed together. This was my second try. I plumbed the first one together, and the bottom module had a bad coolant loop. I had a leak, so this box has been fully assembled twice now. There it is with the cover panel on the electrical side. Got the 2-aught cable on the back. This box is in the middle of the pack, so it'll come from the trunk to this box and then up to the top box. I 3D printed an isolated mount with some reinforced mounting holes. This is for a Pyro Fuse. This is a fuse that Tesla developed when they started blowing fuses as they were adding power to their motor. They couldn't use a standard fuse. So this one monitors the amp load, and if there's a short, it'll blow just like an airbag. Now that that's all mounted in the box, I had to tip it on its flat side, get it ready to install in the car. So this is just using a cherry picker and a couple of slings. Worked real easy. I designed this box to fit in the car, so it is a tight squeeze with the radiator in, but I took my time and lowered it down in. It was nice to get some weight on the front of this car finally. This is about 400 pounds, so started to squat the front suspension and give me a look at what the ride height's going to end up being. There'll be another 4 modules sitting on top of this, along with the 6 that'll be in the trunk. So this one sits nice and low, and then leaves some room for 4 more on top. The front and back panels, as well as one side panel, are removable. So this is what it looks like in the car from the back. You can see those 6 modules on edge. Pretty cool. I'm starting to get excited. This is getting real. Next step will be passing some wires into the trunk, working on the trunk box and the upper top box. Slowly but surely making some progress. I'll be driving this car this summer. Thanks for watching.